Hi everybody, in this video I'm going to go over a review of Unit 1 in chemistry. I'm going to go over some practice problems for each review standard, and so if you already understand some of this, you can skip forward to the learning standards that you're struggling with. But here we go, let's start with standard 1.1, which goes over measurement. So for this, we need to be able to look at a graduated cylinder and figure out the measurement, okay? So here, if you remember, there's this curve here, and this is called the meniscus. And we measure from the bottom of it. Okay, so that means we're gonna look at this and we're gonna say, okay, the bottom of the meniscus is about here. So that's where we're going to be measuring from. We're not going to be measuring from up here because that would give us a different value. All right, so let's look at our increments here. So this is 6 and this is 7. Let's see, between we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this is measuring to the nearest 0.1. Right, because there's 10 of those lines between 6 and 7. Okay, and that means our uncertain digit will be to the nearest 0.01, okay? Because it's one digit more than what it's measuring to. So we know for sure that this here is about 6.6, right? Because we know it's above that 6.6 line here. So I'm going to say this is 6.6, but then I need one more digit that I'm estimating. So I'm going to say 0. Okay? These are our certain digits. And this would be my uncertain digit. Okay? And I need to include my unit, and for volume, this is milliliters. So we know the certain digits are the ones that have lines. Right? So the 0.6 has a line, the 6 has a line. The 0 we're not sure about, so we're leaving that as our uncertain digit. And if you put here 6.62, 6.25, 6.65, I would accept those things as well, okay? As long as you include that uncertain digit. Let's look at another example. Again here, we're gonna look at this one, okay? So we can see there are lines 1, 2, 3, 4, 5. There are lines every 0.2. Okay. And so that means we're going to have our uncertain digit is to the 0.1, right? Because 0.2 is certain, so our uncertain is going to be 0.1. So if we look at this, again, we're looking at the bottom of the meniscus here. This looks like it's 3.2, 3.4, 3.6. So it's between 3.4 and 3.6. So I'm going to say this is 3.5 milliliters. And here, this is my certain digit, and this is my uncertain digit. Okay. Let's look at the last one over here. This one only measures to the nearest 1. So that means our uncertain digit is the nearest 0.1. Okay, so let's look at this line here at the bottom of the meniscus. I know it's between 1 and 2, so my measurement is going to be 1 point and then something. Let's say 5. Okay, and again, this is my certain digit because I know it's above that 1, and this 0.5, this is my uncertain digit. Okay, because I know it's between 1 and 2, but I don't know what exactly that volume is. So the big idea here is to look at the lines and include everything that has a line. Those are the certain digits and one estimation for between the lines, and that is your uncertain digit. That's standard 1.1 on measurement. Standard 1.2 talks about significant figures, okay? So For this first question here, we're going to look at how many significant figures there are in a given value. And for this, we need Atlantic Pacific rule, right? So if our decimal is absent, we start counting from the Atlantic side. If our decimal is present, we start counting from the Pacific side, starting with the first non-zero. Okay, so let's look at this first number here. This has decimal point is absent. So I'm going to start counting from the Atlantic side, the left side. So let's take a look. I'm going to zoom in a little bit. Okay, starting from this side, this doesn't count because it's a 0. This doesn't count because it's a 0. This doesn't count because it's a 0. This counts. So we're going to start counting 1, 2, 3, 4, 5, 6, 7. This has 7 significant figures. We notice that even this here, even though it is a 0, once you start counting, you just keep on counting. So this has 7 significant figures. Let's take a look at this one. Here we have the decimal as present. So we're going to start from the Pacific side, starting with the first non-zero. So over here, let's go, okay, starting from here. This doesn't count, this doesn't count, this doesn't count, this doesn't count, this doesn't count. Here we go, start counting. 1, 2, 3, 4, 5. Okay, so this has 5 sig figs. I'm abbreviating significant figures. Notice again that even though this one is a 0, once we start counting, we keep counting all of them. So this has 5 significant figures. We also have the situation here where this is a number in scientific notation. So for scientific notation, you count everything before the times 10. To the whatever number. That n is any number. Okay, so here we're just going to count this section here. So I'm counting 1, 2, 3. And this has 3 sig figs. Okay. So when we're finding significant figures, if the decimal point is absent, we start from the right. If the decimal point is present, we start from the left. And if we have scientific notation, we just count the numbers before the times 10. But what if we want to round? Let's take a look at some examples of this. So this says round each to 2 significant figures. So if we have a large number like this, no decimal, we're going to start from the left. We go 1, 2. Now this number here is going to tell us if this rounds up or down. So if your number is greater than 4, you round up. If it's less than 4, you stay the same. Okay? So looking at this, 1 is less than 4, so it's going to stay the same. So we put 5, 4. But now we can't round. This is 5,419,008. We can't round that 5 million number to just 54 because that wouldn't make sense. So we need to add placeholder zeros here. So for this, I'm going to put my 0, 0, 0, 0, 0. So we need to add those placeholder zeros. So this would be my answer, 5,400,000. Okay. So for a large number, we add placeholder zeros to the right. Okay, let's look at this other one here. This is a small number. Okay, so here we are going to start counting after the first non-zero. So we're going to count here, 1, 2. Okay, now this is the one that's going to decide, does it round up or down? and it's the same, so it's staying, okay? And so this would become 2/8. Now, for a small number, we can just get rid of what's left on the right. But we need to keep these placeholder zeros here. And the decimal. Okay, so my answer is 0.00028. So here you need to add placeholder zeros to the left. Okay? So basically you just want it to be about the same size number, right? So if you have a number in the millions, you need to end up with a number rounded in the millions. This one is the tenths, hundred thousandths. This one is in the 1 millionths. So you need an answer in the 1 millionths as well. Okay? Great. Let's move on to our next standard, 1.3. So standard 1.3 is about dimensional analysis. Okay? So for dimensional analysis, we're always going to have our given value. And we're going to make our train tracks and always put that given value here. Okay? So let's put that number, 58 milligrams here. Notice I'm keeping the unit. Now, we need to use our prefix table to find our conversion factor. Okay? So I have to find M. M is for milli, that's here. And this is the number. And how I read this is I say, okay, 1 milligram is equal to 1 times 10 to the negative third gram. So this is our conversion factor. Okay. So now, on the bottom here, we need milligrams to cancel. So we need milligrams to be here. So that means I have to look at this and I say, okay, I have 1 milligram. And then whatever 1 milligram is equal to, that's what's going to go on the top. 1 times 10 to the negative third gram. And now we're going to see that milligrams is on the bottom and the top, so it cancels. And so the unit we're going to be left with here is grams, which is what we wanted. Okay, so now we're going to multiply by the top and divide by the bottom. So in this case, we're going to say in our calculator, 58 times parentheses 1 times 10 to the negative third, close your parentheses, divided by 1. And we're going to get an answer of 0.058 grams. And that's our final answer. So in this situation, we put our given value in the top left. Then we used our prefix table to find the conversion factor between milligrams, and grams. We put it in so that milligrams would cancel. Then we multiply by the top and divide it by the bottom. Let's do one more example. In this example, we're using dimensional analysis to convert 28 inches to centimeters, and we're given that 1 inch is 2.54 centimeters. Now let's look at how this is different from this one. In our first one, we're converting between two metric ones. Okay, this is metric. Here we're converting between English and metric. So if you're just converting between different metrics, you're going to use the table of prefixes. But if you have an English unit too, then I have to give you the conversion factor, which would be in here. Okay? So we're setting it up the same way. Let's try and draw a straighter line here. There we go. And our given value always goes here, 28 inches. And we know 1 inch is 2.54 centimeters. And on the bottom here, we want it to cancel, so we need the inches down here. So I'm going to put 1 inch here because that's what I have here. And 1 inch is equal to 2.54 centimeters. That's what I had here. And so now we're going to see that inches on the bottom and inches on the top, so they cancel. And we're going to be left with a unit of centimeters. So now we multiply by the top and divide by the bottom. So I'm putting in my calculator 28 times 2.54 divided by 1. And I get an answer of 71.12 centimeters. And that's my final answer. Again, we put in our given value, we used our conversion factor and put it in so that the top and the bottom canceled. We multiply by the top and divide by the bottom. Okay, let's review this last standard, which is density, 1.4. One thing when we're talking about density, we need to remember that density equals mass divided by volume. Okay, so here we have an object with a mass of 38 grams, has a volume of 27 milliliters. What is the density of the object? So I'm just going to plug right in. Density is equal to our mass, which is this, 38 grams, divided by our volume, which is that 27 milliliters. And then I just plug that in a calculator, 38 divided by 27. And I get 1.4 grams per milliliter. Our unit for density is grams per milliliter. So now it's asking us, will it sink or float in water? Okay, so water has a density of 1 gram per milliliter. So if an object's density is greater than 1 gram per milliliter, it's going to sink. And if it's less than 1 gram per milliliter, it'll float. Okay, so looking at this, I see this is greater than 1 gram per milliliter, and that means it's going to sink. Okay, so I just found the density by dividing the mass by the volume, and then I compared it to 1, right? So 1.4 is greater than 1, so that means it's going to sink. Let's do this last one here. Here we have an object with a mass of 14 grams, has a density of 0.82 grams per milliliter, and we're looking for the volume. So we're going to plug into the same equation. So our density is 0.82 equals our mass is 14, and our volume we don't know. So now we're going to have to use our algebra skills to solve for V. To start doing that, I'm going to try and get V by itself by multiplying it on both sides. Now I have 0.82 V equals 14. And I see that the V is not yet by itself. So I have to divide both sides by 0.82. So I have V equals 14 divided by 0.82. So I'm just going to put that in my calculator, 14 divided by 0.82. And I get a volume of 17 milliliters. And that's my answer. We can see that our equation is density equals mass over volume. So while in the first one, we were given the mass and the volume, and we had to find the density, in this case, we were given the density and the mass, and we needed to find the volume. So you can have problems of all types, and you're just going to plug in the numbers into this equation and then use your algebra skills to get it by itself. Thank you so much for listening to this review. In this, we went over each of our standards for our test. Review standard 1.1 is about measurement. 1.2 is about significant figures. 1.3 is about dimensional analysis. And 1.4 is on density. Thank you for watching. Hopefully that was helpful, and good luck on your test.